All right, for the next question, number six, it says calculate the grams of sulfur dioxide that would have three times the number of molecules as 75 grams of iodine. This question, it's a bit intimidating to a lot of students, and I will tell you why. First up, when people see iodine, they might not realize that it is actually I2, not just a single I. Okay, and the reason for that it's like O2. I mean, oxygen it's O, but it doesn't exist by itself. Especially we finished the unit of drawing all the molecules, right? We know that molecules must exist when they are stable, when they're octets. So I cannot exist by itself. So based on context, this is clearly about I2, not I by itself, okay? And a couple more things that would scare people away, like sulfur dioxide, the grams, and then you have three times the numbers. So before we start, we have to understand the logic. And to start, like I said, do you understand molar mass? Because if you understand molar mass, the moment you see 75 grams of iodine, you would look up the periodic table and say, hey, what's the molar mass of I2? And that is 253.809 grams per mole. So you'd be like, oh, hey, if I know the number of grams of iodine, I shall know the number of moles of iodine, like how many groups there are, how many moles there are. And then we say, oh, you know what? You want to have three times the number of molecules, right? So that means every one mole of I2, it's to 3 moles of SO2. Okay, 3 moles of SO2. That's a ratio. Okay. All right, so it's just like this. It's like if you donate $1, I would donate $3. Okay, every single dollar you donate, I would donate three times more. So if you donate 20, I'm going to donate 60. Okay, that's the understanding. Okay, simple logic, but it's being phrased a little bit, um, just being phrased in a new way that you might not have seen before. So that's where intimidation comes in. All right, and then we say, hey, what about the grams of sulfur dioxide? Well, if you follow the logic, and let me go ahead and write down the logic right here. You have mass of I2. And like I said, if you know the mass of I2, then you should know the number of moles of I2 because you know the quantity. And then if you know the moles of I2, then you should know the moles of SO2 because you know it's three times as much, right? And if you know how many moles of SO2, then you should know the mass of SO2 because, well, if you know the moles, you know the mass. That's the basic core understanding of molar mass. If you have mass, you shall know the mole and vice versa. So this is the thought process before we even start computing any numbers. Do you have your thought process ready? That is the key. If you have your thought process ready, then we can start putting in the numbers. Now, just a little comment about significant figures. If they give you 3 sig figs, chances are you're going to present your final answer with 3 sig figs. But along the way, you just write down the molar mass based on what you calculate, what you got from the periodic table. So one mole of I2, it's to 253.809 grams of I2. And then what? And then we say, oh, you know the moles of I2, then every single mole of I2 is to 3 moles of SO2. 3 times the number, right? It's gonna be more. And that's why we multiply, not divide by 3. Right, and then if you know the moles of SO2, then you should know the mass of SO2 because from the periodic table we found out that the molar mass of SO2 is 64.064 grams per mole. So 64.064 grams of SO2 per 1 mole of SO2. Now, I'm not going to worry too much about the final answer, okay? The final answer, it's just a matter of you typing in the numbers correctly. What I am concerned more is that are you able to write out all the steps, all the computations needed to use your calculator? Okay, it turns out that it is 56.79, which we will round up to 56.8 grams of SO2. Okay, now let's go ahead and do a little bit of what is it called? Approximation. All right, a little bit of approximation. How many mole of I2 is there if we don't use the calculator? And we say, well, this is 253, right? So 0.1 mole is 25. So this is roughly 0.3 moles, right? This is roughly 0.3 moles of iodine. Okay, 0.3 moles. And then, and hey, this is 0.3 moles of iodine, and you have 3 times as much. That means we're going to have around 0.9 moles of 0.9 moles of SO2. And then we say what? Well, for SO2, 1 mole is 64 grams. Okay, for one total mole, one group of SO2 molecules. Okay, 1 mole of SO2 molecules, one group of SO2 molecules, it's going to be 64 grams. But hey, we don't have 1 mole, close, but not as much as 1 mole. So we expect a number slightly less than 64. Well, we got a number slightly less than 64. So far, so good. All right. That's how you use approximation to quickly check your answer and say, hey, mentally, it all makes sense. Now, let me go ahead and make a little quick comment. At the very beginning, this approximation skill is going to take you some time. It takes practice, okay? It will not be fast, straightforward at the beginning. It is okay, but you must learn how to approximate if you want to get an A. Okay, if you are not aiming to get an A, that's not an issue. But if you say I want to get an A, I want to continue for AP Chemistry in the future, then I would strongly advise you that please learn how to approximate. It is a very essential skills. It is a very essential skill that a lot of teachers, a lot of schools, they are not teaching, and you need it. You very much need it. Okay. And you will become extra powerful if you can master this calculation skill.